All right, so this is going to be for the 1B1 video, but before we jump into 1B1, I needed to cover this very last example on the 1A4. It looks like we maybe just looked over that we had one more slide on that Kahoot. But anyways, it says express the value as a power of 10. Hint that 10 to the first is 10, 10 to the second is 100 because it's 10 times 10, 10 to the third is 1,000, 10 to the fourth is 10,000. If you notice the pattern here, it's like whatever the exponent is, we have a 1 followed by that many zeros. So to then write 100 trillion as a power of 10, we would count how many zeros there are. So this is going to be 10 to that'd be 3, 6, 9, 10, 11. There's 11 of those. Yeah, so let's see, 3, 6, 9. I think this was actually 100 billion. Yeah, sorry, I said 100 trillion. So this is 100 billion. And then for this one, we have, let's see, this would be ones, thousands, and then we have millions, and this will be 1 billion. Notice that's still going to be 10 to a power of, there are 9 zeros after the 1, okay? And then this one is 10 million as a power of 10, so that's 10. There's 6, 7 zeros, essentially. So this is just a nice way for us to shorthand anytime you have a 1 followed by nothing but zeros afterwards. So what that tells us is 1 million is 1 followed by 6 zeros, so that's going to be 10 to the 6th. A billion is another group of 3 more than that, so 1 billion would be 10 to the 9th. 1 trillion then would be 10 to the 12th, because again, every time you jump one more group of place values, you are jumping up by 3 more zeros. Okay, so now let's switch over to the 1B1. Now I had most of 1B1 already pre-recorded from my Tuesday, Thursday class, but I did not have the first couple examples, so I want to make sure we are getting that done before you watch that video. So it says we're going to be multiplying and dividing with scientific notation to follow directions in Newton about your final answer. So sometimes the answer will be asked to put in standard form. That means you write it as a regular number. So is it a whole number? Is it decimal form? Whatever it is, okay? Others will require your decimal to be rounded to a certain place, so make sure you read that. Some require the final answer to be proper scientific notation. It'll just say scientific notation, but it needs to be proper. And like I said, the second video will cover what that is. So if you complete a multiplication or division of scientific notation terms, the result will not always remain in scientific notation. But if you need it to be in scientific notation, if the result does not have a single digit 1 to 9 to the left of the decimal, then you have to adjust it using LARS, which we're going to talk about in this next video after this one, to keep the value in the correct format for scientific notation. Okay, so before we can do that, so like I said, this video is just to preface some of the other ones. We need to talk about the product rule of exponents and the quotient rule. So essentially, if you look at this, this is multiplying two bases that are exactly the same together. They're both base 10. So is this. This one, we're dividing the base 10s, okay? So when you're doing same base times same base, or same base divided by same base, we have a rule for the exponents. And it kind of makes sense if you think about it. Because remember, 10 to the 7th means you write 10 7 times, right? I'm only going to do this on this first one. So 3, 4, 5, 6, 7. So that's 10. Sorry, some of those are like 16s. That's 10 to the 7th written out in long form. And then 10 to the 6th would be 10 times 10 times 10 times 10 times 10 times 10. Like I said, these look like 70s because it wants to keep the ink connected. Anyways, it's 10 6 times multiplied together. So if you count it up, since this is also times, if you counted up how many 10s altogether we had, what you'll notice is that is 13 of them. There's 7 blue and 6 of the red. So that would be 10 to the 13th. Now, we don't want to have to write out all of these expansions of our exponents. That would take forever. So the rule is you add the exponents if they were same base and you were multiplying. So 7 plus 6 is 13. Now that rule is really handy, especially when we get things like negative exponents. So this, according to the rule, should be 10 to the 14 plus a negative 6. So 14 plus negative 6, if you type that in your calculator, you'll get a positive 8. Okay. Now, when we're doing division, again, I'm going to write this first one out just because everything's positive exponents. It makes it easy to see this. We have 5 10s on top. So 1, 2, 3, 4, 5. And we're dividing that by the 2 10s, 10 times 10, 10 squared on the bottom. Now, when you're dividing, every 10, when you look at this, every 10 that's on top can reduce with one of the 10s on bottom because everything's multiplication on both parts. So 110 with that one, 110 with that one. That leaves us with 10 to the third. A way to use the exponents to get that is we do the top exponent minus the bottom exponent. So 5 minus 2. So it's always the top exponent minus the bottom exponent. So if I use that rule to help me on this one, that would be 10 to the 7 minus, and we have to be really careful because this is already negative. So you're going to write minus a negative 2. The rule says to subtract, but you're subtracting a negative number already, okay? Now, anytime you see minus a negative, you could type that in your calculator using, a parentheses to help you see it, but minus a negative actually ends up being plus. So this is 10 to the 9th, okay? Now, so that's going to help us with this next part. We're going to multiply and divide scientific numbers together, essentially. So we've got 3 times 10 to the third, and we're going to times that by 2.1 times 10 to the second. When you're doing this, you're going to do number part times number part, and then we're going to worry about the base 10s, okay? So multiply the numeric part, 3 times 2.1, since everything's all times, is 6.3. Leave the base and add the powers like we did earlier. So 10 times 10, remember we're adding those exponents. So 3 plus 2 is 10 to the 5th. Then we write those two parts together as our final answer, and we do check this before we say it's our final answer. Is it proper scientific notation? And the answer to this first one is yes, because the number in front of your decimal has to be a digit from 1 to 9, and it can only be one single digit. So you can't have like 2 of those, okay? And it can't be a 0. And then this has to be an integer, so no decimals or weird fractions in your exponent, okay? All right, so since we meet scientific notation already for that, we're good on that answer. Now, I believe I start the next video on this one, but just in case, I'm going to go ahead and do it here too, and then I know for sure we'll be good. So on this one, we're going to multiply the number parts together. So we need to do 2.3 times 3.2. I'm going to do that off the side on my calculator. 2.3 times 3.2. I get 7.36 for that part times 10. And then this is 6 and a negative 3 added together since we're multiplying our base 10s together. So that's going to be a positive 3. And this is proper scientific notation. One digit from a 1 to a 9 in front of the decimal point, integer for the exponent. All right, that's the end of this video. The next video we'll pick up either right with that same problem and do it again, or it'll be on the next one. Okay.